All right, so today we're going to be starting off by taking a look at whether f is even, odd, or neither. So start by writing down these two problems, and then we're going to have to start trying to remember what makes them even, odd, or neither. So once we have these written down, then we got to figure out if they are even, odd, or neither. And in order to do so, you have to remember what the definitions of even are and odd are. So for even, there's two different ways you can look at it. In fact, the same is going to be for odd. There's the graphical way, and there's the more algebraic way, although of course they interrelate. If you didn't remember what makes a function even or odd, this would go into your notes right now. If you did, and you remember all of that perfectly, well, then you don't need to necessarily write it down. But I think most people need to write at least part of it down because it's easy to forget some of these details. And then once you have those written down into your notes, go back to those two problems that you wrote down and start figuring out, would they be even or odd? All right, so in order to figure out if one of these things is even, odd, or neither, we have two methods available to us. There's that first one that you put down to your notes, which is looking at the graph and seeing what's happening. Although, of course, graphs can go on and do interesting things outside of our graphing range, so sometimes that can be a little bit hard to tell for sure, even if you know exactly what the graph will look like. So I'm going to stick with algebraic for both of these because it'll always be reliable. So for our first one then, I'm going to do that by figuring out what does f of negative x equal. So we're going to take that negative x and plug it in place of just plain old x. So I have a negative x squared now on top, and on the bottom the x to the fourth becomes a negative x to the power of 4. All right, now when we go and do this, what does the negative x squared on top give us? X squared, yeah. Because if you square a negative, it gives you a positive. No matter what you square, it gives you a positive. So negative x squared is going to be the exact same thing as x squared. The fact the negative is inside the parentheses is the important part there. As you are writing it down, make sure you put parentheses around that negative x, because if you leave them out, it means something different. All right, and then on the bottom, we're doing negative x to the fourth power. Well, is that a positive or a negative x to the fourth? It is positive. Because if x is to any even exponent, the answer is always positive. So we work through it all, and we can see that f of negative x equals x squared over x to the fourth plus 1, and then we need to make our decision. We did the work, now we need to make the choice. Does that mean it is even, odd, or neither? It does mean even, yeah. And the reason it's even is because in our definition for an even function, f of negative x equals f of x. So in other words, when I plug negative x in here, I end up with the exact same thing that I started with. And that is indeed the case here. So that's what tells us it is even. Now, if you haven't done so already, repeat the process with the second function and see if that is even, odd, or neither. All right, so on to the second one here. When we cube a negative, does it give us a positive or a negative? It gives us negative. And so in this problem then, when I go up here and I do this negative x cubed, it ends up switching this sign because it gives me a negative x cubed as an answer. So my plus became a minus there. And then over here, with my negative x to the fifth, well, negative x to the fifth equals negative x to the fifth. So then my minus becomes a plus here. And so this is our equation for f of negative x. Now conclusion time. Is it even, odd, or neither?
At this point, couldn't it be odd or neither?
It can't be odd or neither. It has to be one of them, but it can't be both of them.
That's odd.
So the way that we can tell here is if it was odd, f of negative x would have to equal a negative f of x. Or in other words, it would have to equal the same thing that we started with, except flipping the signs of everything, making it the same as multiplying the entire original equation by negative 1. Which is very close, because we did flip this sign and we did flip this sign, but That 1 in there is causing us trouble. Yep. Because that 1 would have to be negative for us to have multiplied everything through by -1. So since that 1 is still positive, but everything else flips signs, this one's actually neither. A little bit tricky there, right? Got to check all those little details. But remember, it's the same as multiplying the entire original function by a -1. And I say that with that emphasis because you're going to see some questions where you really have to think through what that means and doesn't mean.